This is the lesson on the number system. In this lesson, we will look at the type of numbers, prime numbers, and the sieve of Eratosthenes. What is a number line and the size of numbers? What are recurring numbers? And how to arrange numbers. We begin by looking at the number system. The number system was invented so that problems could be solved. To help us with counting, we use natural numbers, which starts from 1, 2, 3, 4, 5, 6, 7, and so on. However, to solve 3 minus 3 equals to 0, we need to include 0 into the set of natural numbers to give us a new set called whole numbers. And to solve addition, subtraction, multiplication, including 3 minus 5, which gives us a negative number, we need to put in negative whole numbers into the set of whole numbers to give us the set of integers, which comprises of negative whole numbers, positive whole numbers, and 0, which is a neutral number. To solve sums on division, such as 3 divided by 5, which gives us a fraction or a decimal, as the set of integers are only whole numbers and 0, we need to add in fractions and decimals to this set to give us a set of rational numbers. Rational numbers are those numbers which can be expressed as a fraction. However, there are some numbers like root 2, pi, 3 plus root 5, pi over 6, or any combinations of these numbers are numbers that cannot be expressed as fractions. So a separate number set must be made. We call them irrational numbers. But in order to solve all problems, we need to put the two sets of numbers together, rational and irrational, to form a bigger number set called real numbers. We'll now look at a diagram showing how the numbers are related. The natural number set is the smallest set, and when we add in a 0 to this set, we get a set of whole numbers. And if we put in negative whole numbers together with positive whole numbers and 0, it forms a set of integers. And fractions and decimals, as well as whole numbers, form the set of rational numbers. Notice that whole numbers can also be written as a fraction. However, those numbers that cannot be expressed as a fraction is in a separate number set called the irrational numbers. And putting the two sets together, it forms the set of real numbers. Whole numbers can be divided into even numbers and odd numbers, such as odd numbers are 1, 3, 5, 7, 9, 11, and so on. Even numbers begins with 0, 0, 2, 4, 6, 8, 10, and 12, and so on. Together, these two sets forms the whole number system. Natural numbers can be divided into prime numbers and composite numbers. Prime numbers begins with 2, which is the smallest prime number, and an even prime number, 3, 5, 7, 11, 13, and so on. Prime numbers only have two factors, 1 and itself. For example, the factors of 5 are 1 and 5, and factors of 7 are 1 and 7. Composite numbers, on the other hand, has 3 or more factors, or more than 2 factors, such as 6 has 3 factors, 1, 2, and 3. Similarly, 9 has the factors 1, 3, and 3. There are 3 factors of 9. Next, we will see a method on how we can get prime numbers from 1 to 100 using a method called the sieve of Eratosthenes. In this method, we begin by drawing out a table 1 to 100, and we first crossed out 1, which is not prime because it has only 1 factor. Next, we look at the first prime number, which is 2, and we crossed out all the multiples of 2. Once we have finished, we look at 3, which is the next prime number, and crossed out all the multiples of 3. And similarly, for the next prime number 5, we crossed out all the multiples of 5. And finally, we look at the prime number 7 and crossed out all the multiples of 7. What we have left are all the prime numbers, which is in the yellow squares. They are altogether 25 prime numbers from 1 to 100. Next, we take a look at a number line. A number line can be used to represent numbers. In this case here, this is a whole number line. This is an integer number line. Let us now see how we can use this number line to represent number sets. But before we do that, let us take a look at what a number line is made of. The whole number line begins with 0 and is divided into equal spacing. Each spacing represents 1 unit. On the right hand side, we have an arrowhead, which indicates that it continues to a very large number. For representing number sets as such as even numbers which are less than 6, we use dots on the number line to indicate this set. Even numbers, as we know, begin with 0, 0, 2, 4. Since it's less than 6, it does not include 6. Therefore, there are only 3 members. Next, we look at prime numbers between 2 and 7. Once again, the word between means that 2 and 7 are not included in the set. The numbers in between, the prime numbers in between, are 3 and 5. In the next example, we look at representation of a number set. This set is 1, 3, 6, 7. And to represent set A, we have the numbers 1, 3, 6, and 7 indicated on the number line by dots. Next, we look at negative integers greater than -3. Since it's greater than -3, 3 is not included, and since it must be negative numbers, therefore it is only -2 and -1. On this side here, we have all the whole numbers, positive whole numbers, and 0, which is a neutral number. So there are only 2 answers. Note that numbers to the right are bigger than numbers to the left. Therefore, -1 is larger than -2. and negative 2 is larger than negative 3. And all the whole numbers, the positive whole numbers, are larger than the negative whole numbers. For positive integers less than or equal to 4, we use a symbol such as this, which means that 4 is included. 4 is also a positive integer, and we have 1, 2, 3, and 4. 4 positive integers. Let us now take a look at some special numbers called recurring decimals. These numbers appear to go on forever, such as 0.343434 and so on, 5.23333, and 0.1234, 1234, 1234. We need to find a simple way of writing this. We use a dot above the repeated number to indicate that the number is repeating, and 2 dots to represent a set of repeating numbers, 1 at the beginning and 1 at the end. We look at some examples. If 3, 4 are the repeating numbers, we put the dots on 3 and 4. So this is a shortened form. Similarly, 5.2333, 3 is the repeating digit. We put a dot above 3. And in the last example, 1, 2, 3, 4 is repeated. Therefore, we put 1 on top of the repeating sequence and 4 at the end of the repeating sequence. Notice that the maximum number of dots is only 2. Recurring decimals are not irrational numbers because they can be written as fractions. We now take a look at a method to convert a recurring decimal to a fraction. We use the method of algebra, where we let x be the recurring number. Multiplying x by 100 will take out the recurring number as a whole number. By subtracting 100x minus x and subtracting 13.1313, the recurring decimal is taken out, giving us a whole number. And dividing by 99, we will get a fraction 13 over 99. Now, if we continue to do this for several numbers, we can observe a pattern. This method gives us an interesting result, which is the number of repeated numbers correspond to the number of 9s in the denominator, such as 237 over 999 would mean 0.237237 being repeated. And if we have a recurring number, which is 72345, then writing it as a fraction, we have 72345 over 99999, corresponding to each digit in the recurring number. We have to note that fractions must be reduced to the lowest term after it's being converted. Let us now take a look at how we arrange numbers. Numbers of the same type can be easily arranged. For example, if we want to arrange these numbers in ascending order, which means small to big, we need to write them all in the same type of numbers. That is, we are going to convert all of them to decimals. Once they are all in decimals, then we can rearrange them. We know that negative numbers are smaller than positive numbers, so we put negative 3.5 first, followed by 3.0, followed by 3.2, and finally 3.21. Now, since these are not the numbers that we want to arrange, we need to convert them back into its original numbers. Hence, this is the result that we want in ascending order. In the next example, we want to arrange some recurring decimals in descending order, that is from big to small. To do that, we rewrite the decimals in its longer form. And by looking at the decimal places, we pick out the largest number, which is 4.233, and so on. The next larger number is 23. Oh, sorry. This is wrong. It should be 4.23131, which is the next larger number, since it's 4.23131. And the next larger number is 4.2312. Okay, this is 2313, 2312. And finally, we have 4.23. And once again, we need to rewrite them into its original form, 4.23 recurring, 4.231, and 4.231 recurring, and 4.23 in descending order. This completes the lesson on numbers. Thank you.